Einen schönen guten Tag und herzlich willkommen in der bayerischen Küche mit Frau Altmiller. Heute backen wir frische, leckere Brezel nach Münchner Art.
Frau?
Entschuldigung?
Wrong class.
Wie bitte?
These are really good, but it's the wrong class.
Falsche Klasse. Falsche Klasse.
This is chemistry.
Yo, wrong class?
To another fabulous Friday Funday. I'm your host, Mrs. Zygnerski, and welcome to my kitchen. In today's episode, we're going to learn all about bubbles. Yes, those fun, magical things that we love to play when we're a kid. Okay, so even while we're still adults too. All right, so did you ever wonder what goes into a bubble? I mean, we know that it's made of soap. And there's probably some water because it's a liquid. But what makes a soap bubble is that it's actually a thin layer of water that is actually stuck between two layers of soap molecules. Now, if you notice, a lot of them are starting to burst. And if you think about it, it kind of makes sense when they burst, because what's soap supposed to do? Right, remove dirt from your hands, as well as some of the oils. So whenever it comes in contact with some of the oil and the dirt, or even a sharp edge, we hear that pop. Now, did you also ever notice how that when you blow a bubble, they all seem to just go down? Right? They don't float like a helium balloon, but they actually go down. Well, it has everything to do with density. And density, as you probably learned in class, is that it's mass over volume. So how heavy that material is, what it weighs, compared to the size, the volume that it takes up, the space that it takes up. So if we think about this, what is in the air? All right, what is air actually comprised of? It's not pure oxygen, thank goodness. Otherwise, when you light a match, the whole world would go on fire. That would be bad. So, that being said, if you think about it, if I remember correctly, 78% of the air is nitrogen, and 20 some odd percent is oxygen, and the rest is other stuff. So, before I go more into density, I'm going to do a side reaction and then help to explain a little bit more about density. And if you notice, I have out our old friends vinegar and baking soda. Now, as you guys know, or should remember, that baking soda is also called hydrogen bicarbonate. All right, so I'm going to put some hydrogen bicarbonate in the bottom here. All right, and you guys know what's going to happen when I put in the vinegar, acetic acid. What's going to happen? Right, it's going to react, and you're going to see all the bubbles, and you're going to hear a lot of that fizzing that's going to happen. Right, that usually comes with it. Now, vinegar is acetic acid. I mentioned baking soda is sodium bicarbonate. The reaction that's happening, it's actually producing carbon dioxide, water, and sodium acetate. Sodium acetate, guaranteed, if you've ever had salt and vinegar chips, you've had sodium acetate. All right, let's see if I could get this right. Oh, watch what happens when I put some of these bubbles into magic. Did you see that? It was suspended. It was floating. Normally they just go straight down to the cabinet. Cabinet goes straight down to the counter. Now this is a nice little experiment to do for your parents, for little kids, for just about anyone. This is a great little party trick. Now you gotta wonder why. Why was it just kind of floating there when it was in there? Well, remember I mentioned about densities. So when I blew into those bubbles, I had some carbon dioxide that was in there. And we said that the air is also made up of oxygen, nitrogen, as well as other things. Well, let's break it apart. Molar mass is the mass of a material per 1 mole of that material. 1 mole is equivalent to 6.02 times 10 to the 23rd representative particles, aka whatever the amount of the material that there is. So, in this case, when you look at the periodic table, you'll see that oxygen has an atomic mass of 16.00 grams per mole. But oxygen is a diatomic molecule. That means in nature, it is with its twin. So we got to multiply that number by 2. So we'll see that oxygen, O2, is actually 32.00 grams per mole. Then there's nitrogen. Nitrogen by itself is 14.01 grams per mole. But like oxygen, it also likes to be with its twin. So we need to multiply that by 2, and you have 28.02 grams per mole of nitrogen. So we have O2 and we have N2. And then we come to carbon dioxide. Carbon dioxide, 1 carbon, 2 oxygens. So when we add those masses together, it becomes 44.01 grams per mole. All right, so already you could tell that each one of these is at a different mass, and they're going to have different densities. Again, that means a mass within a certain amount of volume. Since we're talking about gases, we are also looking at them in a certain volume, and we're assuming that they're at the same volume. And that's why when the CO2 is produced, it seems to hover at the bottom. Now I know in this container and this reaction, you cannot actually see it, right? These gases are invisible to our eye. Not so much invisible, but colorless. But what happens if we actually use dry ice? So last week when we had the dry ice, we just couldn't help but have some fun ourselves. So we got out a fish tank, we got some warm water, and of course, we put in the dry ice, and we blew some bubbles into that fish tank. I have my safety glove, my hot glove, cold glove, and a hammer. It's hammer time. Going in for my dry ice. So if you remember the last time, I actually made it with an actual annoying noise when it was on the metal. Well, I'm not going to do that again this time. All right, I'm going to spare that from you guys, but I'm going to put some of this into our fish tank. And then, it just looks so cool. Okay. And what's nice about doing it with this way is that you can actually see the carbon dioxide that is there, and that it looks like something out of Harry Potter. And this proves that carbon dioxide is actually denser than air. That is so cool. Oh my gosh, that was so cool. Now, I also showed you how to make a crystal ball, and you're going to notice that I use this container yet again. But in this case, I also use some soap and a dish towel to create the effect. Now, when you look at the bubble that is formed, did you ever notice how it swirls? That the rainbows just keep swooshing around like the clouds in the sky. Well, that has everything to do with the way that the light reflects off the bubble and off of the water molecules and the soap molecules that are within that bubble. And so it has that prism effect. When it hits off a certain angle, it actually has a specific wavelength, and so you get to see a different part of the spectrum. And again, if you think about it, I mentioned earlier that inside a bubble is water, and water is always flowing. The particles are always moving, so it has that swirling effect. Remember how I mentioned last week that there was a fluid, that the gases are a fluid? Well, remember that liquids are a fluid, and it's something that flows, and you could actually see the flowing that is going on within the bubble. So for this experiment, I'm going to need a nice round bowl, some dishwashing detergent, and a towel that I already dampened. And I'm just going to add a little bit of soap. And I'm going to tell you what I'm going to try to do is with our good old dry ice, that I'm going to try to make a crystal ball. So let's see how well this works. Love that. I hope you guys can actually see all the different colors that are on there. This is beautiful. Just proves that this does create a force. Thank you. I'll be here all week. And did you notice that when I put my hand above the bubble, you could see that the bubble was also bouncing with it, and I wasn't even touching it. Again, it's because I'm moving the air, and the air is gas. And with that movement, it's creating pressure. I am actually applying some pressure, compressing the gas in a way over that bubble. And so it bounces in, and then it recovers back up. And that's why it seems like it bounces. And that's all we have today for our Friday Fun Day. Make it a great day. Bye!
Are you eating in my lab? No eating in my lab.
Oh,
Thanks, Frau.
thanks, Rob. They're really good.
Man.
Hey. Oh, you're good. I just had to get a bubble tin.